Hey everyone, welcome to Caltex Academy. Today we're looking at limits, and the method we're using today is direct substitution. So we just substitute the values given here in which the x will be tending towards, either from the right or from the left, to the given function. So we have extremely very simple numbers today. Please subscribe to the channel so that you follow the next videos that will be coming, because we're going to discuss about also indirect substitution and see what tricks are used to find out the limits if direct solutions cannot work. So with this, we have numbers starting from A up to H with different dimensions here. We start with x, and then somewhere we end it with some trick. This is also given around here in our H. So without wasting time, let's dive to our solution, and we start with number A. Now here in our solution, let's copy down our part A of the questions, which says we need to evaluate the limit as x tends to 3 of x. So here we can substitute where there is x, that value of x, that is 3. Now this one is direct, this is just equivalent to 3. Alright, let's move on to the next part, and that is part B. Part B is having limits as x tends to 3 of x plus 2. Now I've expanded the first one a little bit by adding another constant here. So how do you work out this number? Quite simple. Wherever we get x, we will place 3. So we shall have here 3 plus 2 equals 2. And that becomes our solution for part 2. So again, let's move on to part 3. After this, maybe we can move somewhere here and say part 3 is C, and C is limit as x tends to 4 of the function 3x. This time around, we are multiplying a number together with this variable. The second one here, we added the variable to a constant. So let's move on. Now we can substitute where there is x. So we have here 3 times x, and our x is 4. When you multiply this together, we get 12. Easy as that. And then to 4, we have also limit as x tends to -2 of this function 3x over 4. Now this time around, we are also extending it by dividing by a constant. So this one is equals to, again, wherever we get x, we are replacing it with the given value in which x is tending to, and for this particular one is tending to -2 divided by 4. So when you multiply the numerator, you get -6 over 4, and if you reduce it down, you can either decide to write it in decimal or in fraction, or the same. This one goes 1 and 1/2 as the solution. This one also takes us to part E, and part E of the question is, maybe we can scroll to give us more room. So E, let me write it somewhere here, and it is limit as x tends to 0 of a function x squared plus 3x, and then plus 4. This will be equals to, wherever we get x, we plug in 0. So we have 0 squared plus 3 times 0 plus 4. Of course, we know when we square 0, we get 0. Any number multiplies 0 will also vanish to 0 plus our 4. So adding those zeros to 4, just get 4. That is the solution for at E. Then for F, we also had limit as x tends to 2 of a function 2x square plus 4. Now this is equals to, wherever we get our x, we place in 2, then we also square here plus 4. Now we keep on simplifying. If you square 2, you get 4 multiplied by 2. So 4 multiplying 2 will make 8 plus our 4 as the constant. And then when you sum this together, you get 12. And that is the number we have just evaluated. So let's go to G, and then we place G somewhere here. And we have G is given by limit as x tends to positive 2, and then just having certain bracket, that is curly bracket. Any bracket can be used. Some people write without any bracket, it's just still okay. It's your preference on whatever you feel comfortable with. So we have here x squared minus 3 at the denominator. What does this one here equals to? So here maybe let me bring it down here, and then we also plug in the numerator the value that is standing towards this x, that is 2. We have plus 3 all over 2 square. Sorry, it was 3, not 2. So we have here 3, even this one is 3, but it is squared, minus 3. So we can simplify the numerator and also the denominator. So this one is 15 from the first term plus 3, and then the first term of the denominator plus 9 minus 3. So 15 plus 3 is 18. Then 9 minus 3 is 6. If we divide 18 by 6, we get 3. Meaning, when we evaluate limit as x tends to 3 of this function 5x plus 3 divided by x squared minus 3, that is the solution. So lastly, let's look at the next number here, and that number is where our trick is incorporated in, and that is h. So in part h, it says we need also to evaluate limit as x tends to pi. Now the function is tangent of x plus cosine of x. So here as well, we will equate it to, whenever we get our x, we are replacing it with this pi. So we have here pi, then plus cosine of x. This is also pi. Now, if you wish, you can write pi in terms, tangent in terms of sine. So tangent pi can be written the same as sine pi over cosine of pi. And we know pi in radian is equals in degrees as 180. degrees. So sine of pi is 0. Now, if you are working using your calculator, please convert your calculator from degrees to radians, and then when you insert this, it will give you correct results. Again, cosine of pi is -1. From our quadrant, all the precursors here are positive, and then sine is positive, tangent is positive, and cosine is positive. Now remember, 180, this is the pi here, is at this quadrant, meaning cosine of this is negative. That is why we get a -1. So since we're dividing by -1, we're dividing 0 by -1, we will have here 0. So it means tangent of pi is just 0. Now here we'll have 0 plus, and of course I just explained here, the cosine of pi is -1. So you can get here -1. Then this one here goes to negative. As you multiply negative and plus it, it goes to negative. So 0 minus 1, we get -1. So after this time, please, if you have not subscribed, try to do so that you don't miss out those videos that are coming, especially the indirect way of working out this. Not all that glitters is gold, meaning there's some numbers that we cannot substitute directly, just like this one here when it comes to limit. So stay tuned so that we will also see those numbers in action. See you in the next one. Peace out.